Let's start off by talking about when you can multiply two matrices, because you can't just multiply any matrix by any matrix. There's a very specific way that you got to do it. So the easiest way I found is writing the dimensions of each matrix next to each other like so. Let's say I have a 4 by 3 matrix and a 3 by 2 matrix. Now if these two inside numbers here are the same, you can multiply those two matrices, and if they're different, you can't multiply them. And the product, in this example, we can multiply the two matrices, and our product is going to be a 4 by 2 matrix, which is our two dimensions on the outside here. So that's when you can multiply a matrix. Now, what are some rules associated with matrix multiplication? First of all, if you have a matrix A times a matrix B, that does not equal matrix B times matrix A. Okay, unfortunately, matrix multiplication is not commutative, and that just makes our life a little bit more difficult, but it is what it is. Now, what if you're multiplying by more than two matrices? Okay, so let's take a really extreme example here. Let's say we have almost the whole alphabet. We have A, B, C, D, and E. How are we going to multiply these 5 matrices by each other, alright? You'd think you'd start over here and multiply A times B, and then whatever that is, you multiply by C, and then whatever that is, times D, and then so on. Right, but that's not the case. What you want to do is you want to start with the two rightmost matrices, multiply those, and then take that product, and then multiply C by that product. And remember, it's going to look like this. Okay, so the C is going to be the first term in your multiplication when you get to that point. And then you're going to have that group times B, and then B is going to be your first term. Then once you multiply all those, you're going to have A as your first term and multiply them like that. So you kind of multiply from right to left here, but you're keeping the order of left to right, if that makes sense. You're just starting with the two rightmost, and then you're multiplying that product by the third rightmost, and then fourth, and then fifth, and so on. Now let's actually get into the computation here. I mentioned a 4 by 3 matrix earlier, and a 3 by 2 matrix, and I said that we can multiply them because the two inside numbers are the same. And our product should be a 4 by 2 matrix because those are the two outside numbers. Okay, so let's come up with a 4 by 3 matrix here. I'm going to keep it simple. We're going to do 1, 2, 1, 1. So that's going to be our 4 by 3 matrix. Now we have a 3 by 2 matrix. There's our 3 by 2 matrix, and now how are we going to multiply these? So it turns out that matrix multiplication is really weird and kind of dumb, alright? Now I'm not saying that the concept is dumb or anything, it's just not very nice, alright? And the reason it's dumb is just because it kind of takes a lot of work, alright? So the way you multiply this is you multiply the rows of the first matrix by the columns of the second matrix. And you're going to multiply each row by each column. So we've got 8 computations to do here, alright? And it sort of works like the dot product in the sense where you multiply the corresponding terms. So like the first term in the first row and the first term in the first column. And then once you multiply the second and third by the second and the third, you add all those together to get one value. And that's going to be, in this case, since we're multiplying the top row by the left column, that term is going to be in the top left part of our 4 by 2 matrix. Okay, so I know that can be confusing, so I'm going to show you here what I mean. So we're going to start with the first row and the first column. It's got 1 times 1 is 1, plus 2 times 2, which is 4, plus 3 times 3, which is 9. And all that equals 14. So we have our 4 by 2 matrix over here. I'm just going to draw an empty matrix now. And since we're multiplying the top row by the leftmost column, our 14 is going to be in the top left part of our product. Now we're going to multiply the top row by the second column. Okay, so 1 times 4 is 4, 2 times 5 is 10, 3 times 6 is 18. Now if I did my math right, that's about 32. And since we're still in the top row, but now we're in the right column, our 32 is going to go in the top right. Okay, now we continue that pattern for the rest of the rows in our first matrix. So I'm going to do the second row by the first column. Now I'm getting 23. Now since I'm in the second row in the left column, I'm going to put the 23. It will go in that second row left column. Now for the right column second row, I'm getting 53. So that goes in the second row right column. And now these next two rows have lots of ones and zeros, so they should be easier to compute. Again, third row left column, so we're going to have an entry here next. And that's a pretty simple, just 1 plus 3, right? 1 times 1, and then 0 times 2, and then 1 times 3. You add all those together, and you get 4. Now for the right column, still third row. 1 times 4, 0 times 5, 1 times 6, I'm getting 10. And now last but not least, 1 times 1, 1 times 2, 0 times 3. I'm getting 3. And 1 times 4 plus 1 times 5 plus 0 times 6, I'm getting 9. Hopefully I did all that correctly in terms of mental math, and that is how you compute matrix multiplication. But what does this represent? What is matrix multiplication used for? Well, it turns out you end up using it a lot later on, but I'm going to show you here what it means. Alright, let's say you have matrix A times matrix B times a vector X, and that equals some vector B. Okay, so what we're saying here is that this vector X undergoes a transformation that's represented by the matrix B, and then it goes under another transformation which is represented by the matrix A. So that's why you kind of do the backwards order when you're multiplying them, because you're not doing the A transformation and then the B transformation. You're doing the B transformation then the A transformation. Okay, it is a little weird, a little difficult to get used to, but remember that when you're multiplying them, the A matrix does come first in the computation. Okay, so what you're doing is kind of combining these two matrices and then multiplying the X by the product. Okay, and then your new vector, after it undergoes both of those transformations, equals our new vector B. Okay, so I hope that makes sense. Let me know if you have any questions down in the comments, and I'll try to respond to y'all. Good luck on your test tomorrow. I know you'll do great.